Well, we need to finish this. We need to also figure out where the directrix is and where the focus is. Your directrix is always perpendicular to your axis of symmetry. It never goes through your curve. It's always in the outside of your curve. Your directrix and your focus are the same distance away from your vertex, which is right here underneath the crosshairs. Now, your directrix and your vertex are p-value, which is 1 over 4a. So in the context of this problem, since a is 1, really we're only looking at the absolute value of that. So you get 1 over 1 times 4, or you get 1/4. So your directrix is 1/4 of a unit to the right. Well, you're already 3 units over for your vertex. You go 1/4 of a unit to the right, it'd be 3 3/4, or you could write it as an improper and go 13/4. It's a vertical line, so it's x equals, so your directrix then is x equals 13/4. Now, here you're 3 over and 2 up. You then need to find your focus, which is always on the inside part of the curve on your axis of symmetry. So you got to go, in this case, the same distance over. You got to go 1/4 of a unit to the left. If you're just going to the left, it does not affect the y value, so the y value of the focus is still up 2. So you're at 3 and you go 1/4 over, so you go 3 minus 1/4. So you get 2 3/4, which as an improper is 11/4. So your focus is a point, and so you go your x coordinate followed by your y coordinate. Well, for the most part, we need to continue to do pretty much the same thing. But here, all we have to do is get this in the standard form. So we need to go ahead and complete the square. When we look at our problem up here, once again, we have a y squared. Our y squared means we got to get our y all squared, so that means this form here. So we got to get x by itself. So to get x by itself, we'd have to take our y squared to the other side, so we add a y squared. When you're completing the square, you don't want to have a number over here with your x. You want x by itself, so you got to go ahead and divide that side by 4. So therefore, you got to divide everything on the other side also by 4. Remember, in completing the square, then, you want to go ahead and group your y's together. This here doesn't have any y's. You put it afterwards. Remember, dividing by 4 is the same as multiplying by 1/4. And here, this reduces down to half. Now, once again, you need to have only a 1 in front of your y squared. So when you're looking at your parentheses here, you need to factor out 1/4. So we factor 1/4 out of just the parentheses. We don't care about this thing that's after the parentheses. And then we got to complete the square. So you need to go ahead and take half of this, which you would know is 1. Go 1 squared, we put that here. Now, remember, out back here, we always subtract our a value multiplied by what we put here, the 1 squared. Well, here we're going to factor our parentheses. It's going to factor into 2 identical parentheses of a y plus 1 and y plus 1. So we go a y plus 1 all squared. Simplify the back here, and then we'll get 3. So now it's in standard form. That's all we're asked to do with this problem. Now this particular problem, we are asked to come up with the equation of our parabola. The only thing you're given is your focus and your directrix. So the first thing you want to do is you want to go ahead and plot that so you have a visual idea of what's going on. So your focus is 3 units to the left, 2 units down. So I plot that and make a point. Your directrix is a horizontal line, 1 unit up, so we have that. Now remember, your parabola always goes halfway in between these two. So your vertex would have to be here. Well, if it's there, you're still 3 units to the right. Here, your total distance of 3 in between the lines and the point. So half that distance would be 1 1/2. So you go 1 1/2 down from your line, so you'd be at negative 1/2. Now, question is, do we open up down, left, or right. Well, when you're dealing with your parabola, it always curves around your focus and never crosses your directrix. So if we would go ahead and say, well, would it open right? Well, it wouldn't curve around your focus and it would cross your directrix. Same idea if it was going to the left. If it was opening up, it would not go through your, or it would not go around your, that thing there, focus, sorry about that, mental glitch, and it would cross your axes. So therefore, we would know that it would have to go ahead and open down. Well, if it opens down, we know it's going to be y equals. If it opens down, you also know that a is negative. Well, how do you find that value of a? Well, remember the distance from your vertex to your directrix, or your vertex to your focus, is always that 1 over 4a. And in this case, that's 1.5. So you go 1 over 4a equals your 1.5. And then you want to solve it. You may want to write this as a 3 over 2. You'd have a fraction equal to a fraction and cross multiply. When you solve it for a, then you would get 1/6. But remember, since it's going down, you know it's going to be negative. So you're going to have a y equals a negative 1/6. Go x minus your x coordinate of your vertex. So when you subtract a negative 3, you get a plus 3. And then you got to put your y value afterwards. So that would be the equation of your parabola. Now the reflexive property of parabolas is basically if light's coming in from the sun dealing with a telescope, when it hits your parabola here, everything focuses then to your focus, which then becomes the eyepiece. That's the neat thing about a parabola. Is it all light comes in here, reflects back to all to a single point. And so that can be very useful. Now, instead of just having this work for a telescope, you could also have a nice long curved piece like this, have this being the cross section of it, nice long curved piece of a mirror going along and having it come and heat up a tube of water that goes along this way here. And so you could use the solar energy to heat things. Or you can use the solar energy to reflect it all to a nice spot to, say, melt a piece of metal if you had a big enough mirror and the sun was out. So it's really neat how the parabola works that way.